Hello students, in this video we are going to discuss about the allotropes of carbon. Carbon exhibits many allotropic forms, both in the crystalline as well as in the amorphous form. Here we need to discuss some of the crystalline form of carbon, that is fullerenes, graphite and diamond. These are the three well-known crystalline form of carbon which we need to discuss in this video. First, let us talk about diamond. Diamond is quite familiar to us. It is used in making jewelries. Let us talk about the structure of diamond. Diamond have a three-dimensional network-like structure where each carbon is sp3 hybridized and each carbon is bonded to other four carbon atoms by covalent bond. It makes the structure tetrahedral and the overall structure is having a three-dimensional network structures. Because of the covalent bonding here, that is extremely hard and it is non-conductor of electricity. Because there is no free electrons available here, therefore it is a non-conductor of electricity. Let us see the three-dimensional view of diamond. The graphite has a layered structure. The layers are held by the van der Waals forces and the distance between the two layers is 340 pm. Each layer is composed of planar hexagonal rings. As you can see here, each layer composed of hexagonal rings of the carbon atom. Each carbon atom in this, it is sp2 hybridized. That is, each carbon atom in the hexagonal rings undergoes sp2 hybridization and makes 3 sigma bond with the other 3 carbon atom. As is shown here, each carbon it is sp2 hybridized and it makes a covalent bond with the 3 other carbon atoms. But here the fourth electron that is forms a pi bond with the other ring. It forms a pi bond. So the electrons are delocalized over the whole sheet and the electrons are mobile here. Therefore the graphite is a good conductor of electricity. So the structure of a graphite is shown here, that is having consist of hexagonal rings in the two-dimensional structure. Next term is fullerenes. Up to 1985, it was considered that carbon having only two allotropes, that is diamond and graphite. But in 1985, the scientists discovered a new family of carbon allotropes consist of clusters of carbon atoms. These were named as fullerenes. So this exciting discovery by these scientists has opened a new era in the chemistry. And for his discoveries, these scientists were awarded with the Nobel Prize in 1996 in the chemistry. Fullerenes are made by the heating of graphite in an electric arc in the presence of inert gases such as helium or argon. That means the fullerenes can be prepared by heating of graphite in the electric arc in the presence of inert gases. The examples of fullerenes, which is actually cluster of carbon, that is C32, C50, C60, C70 and C84. Among these allotropes having the molecular formula C60 is the important. So let us discuss more about the C60 fullerene. Its structure is quite resembled to a dome, which is actually given by the architect which is called as Buckminster Fuller. On the basis of this, it was named as Buckminster Fullerene. So it is named as Buckminster Fullerene on the basis of the name of the American architect Robert Buckminster Fuller, who have designed this dome that is exactly resembled to C60 Fuller. So that's why it was named as Buckminster Fullerene. So let us discuss the structure of Fullerene. So let us have a look about the three-dimensional view of Fullerene. When we look at the visuals which is shown here for C16 Fullerene, it is a perfect sphere and looks like a soccer ball. Therefore, it is also known as buckyballs. It consists of 5 and 6-membered carbon rings as it is shown in the visuals. The 6-member rings are fused to 5-members ring. There are 26 member rings and 12 5-membered rings. From these visuals, we can say that here each carbon in this is sp2 hybridized, and each carbon bond with the other 3 carbon atoms as it is seen in that images, and the remaining electron is delocalized in the molecular orbitals, which gives aromatic character. So it shows the aromatic character because the remaining electrons it is get delocalized in the molecular orbitals. When we talk about the structure of C60 Fullerene, it have 26 membered rings. 6 membered means hexagonal. When you look at the image, it have a hexagonal ring and there are some pentagonal rings. That is 5 membered rings are also there, 6 membered rings are also there. So there are 26 membered rings and 12 5 membered rings. It has 60 vertices and each one is occupied by 1 carbon. That's why it is called as C60, because 60 number of carbon. Here it has both single and double bonds and it is also called as buckyballs. Its structures look similar to soccer ball and these are also called as buckyballs. So it is one of the important class of carbon, that is crystalline form of carbon, that is fullerenes. It has a very great importance in the different fields that we'll be discussing in the further or in the future classes. So this is all about this video. Have a nice day.